Hi, and welcome to the next lesson in the physics video series on two-dimensional motion. Today we will do a comparison of projectile motion with complementary angles. Let's get started. We're going to launch an object at a speed of 10 meters per second. First at 30 degrees from the horizontal, then at 60 degrees from the horizontal. We're going to show you 4 out of the 5 steps, and we're going to show you which equations to use and how to derive all of the formulas and get the proper answers. In order to find the components of the initial velocity, which is 10 meters per second at 30 degrees, you need to use equations 6 and 7 for solving for Vox and Voy respectively. Whether the angle is 30 or 60 degrees, you're still going to use VO cosine theta for Vox and VO sine theta for Voy. You can see that in both sides here for the 60 degree and 30 degree angle respectively. For the 30 degree angle, we're going to have 10 meters per second times the cosine of 30 and 10 meters per second times the sine of 30. That gives you 8.6 meters per second for Vox, and Voy is 5 meters per second. If you used 60 degrees, it's the exact same equation, except it should say 60 right here instead of 30. And then you would get 5 meters per second and 8.6 meters per second. So complementary angles will exchange the values of Vox and Voy as they do here. And yes, there is a small typo right here. That should say 60 degrees in both of these places. Next, we want to find the time of flight. So the time of flight was equation 3 solved for t and double it. And here's a little reminder right here. Equation 3, solve for t and double it, giving you t is 2 Voy over g. The Voy is given right here from step 1. 2 times the Voy divided by gravity gives you a flight time of 1.02 seconds. However, when you're dealing with a 60 degree angle, the Voy was actually 8.6 meters per second, and 2 times 8.6 over 9.8 gave you 1.7 meters per second. So it can be seen that the higher angle sends the projectile through the air for a longer time. Now let's do step 3 and find the range. Range is equation 1 with the answers from steps 1 and 2. Range is Vox t. Vox for the 30 degree launch was 8.6. 8.6 times 1.02 gave you 8.8 meters. And the range for the 60 degree launch was still Vox times t, which was 5 times 1.77 seconds, which gave you 8.8 meters. You will get the exact same range for complementary angles. The only difference is the higher angle will take a taller path through the sky, but they will both land in the same spot. In step 4, we're going to look for the maximum height of both of those trajectories. Since they're complementary angles, they will share the same range and of course have the same axis of symmetry, but the higher angle will be proved to have a higher turning point than the lower angle. So for both sides of the problem, you would use equation 5 and solve for y. Y max winds up becoming Voy squared over 2g. That's the formula that's going to be used in both equations. That's the formula that's going to be used for both variations of the angle. The Voy for the lower angle was 5 meters per second. That gets squared and divided by double gravity, giving you a maximum height of the turning point at 1.3 meters, whereas the Voy for the higher angle was 8.6 meters per second. When squared and divided by double gravity gives you 3.8 meters for y max, which is the height of its turning point. As I said earlier, the turning points are both on the axis of symmetry. They have the same range, but the higher angle will have a higher y max, and that is why it has a longer time of flight than the lower angle one does. And so in summary, we can see that the steps required for both of these problems, no matter what the angle, is the same. The steps and the equations to solving any projectile problem at a given angle are always the same. To find the components, you use equations 6 and 7. To find the time of flight, use equation 3, solve for t, and double it. To find the range, use equation 1 and the answers from steps 1 and 2. To find the max height, use equation 5 and solve for y. whether you're dealing with a 30-degree angle or a 60-degree angle or any other angle. You'll always use these same steps. I hope you enjoyed this video and thank you for watching. We'll see you in the next video.